Excellent. So as you can see, we were really trying to bring the real world in and to have some relevance in science class. And this week, we have been testing our bridges. Each team has obviously built a bridge, and we're down to our last two finalists.
Experiment. I'm going to drop this and this. Which do you think is going to fall faster? Raise your hand for the water bottle. Just raise your hand for the piece of paper. Alright. Is everyone watching? They fell at the same time. Everything falls at the same speed, 9.8 miles per hour squared. Every second, the speed gets squared.
What if we replaced the crumpled up piece of paper with a flat piece of paper? Which one do you think will land first? Water bottle? Piece of paper. The water bottle landed first because the piece of paper has air resistance on it. So because of the air resistance pushing up, it goes down slower, but it has gravity pushing it down, and gravity is a stronger force than air resistance.
An experiment, we made triangles and squares out of cardboard to see what could hold more weight, because we needed it for our bridge design to see like what we could use. And the triangle can hold more weight because it distributes all the weight to the edges to the ground, so it can stay longer. But a square can hold a lot of weight too if you put a truss through the middle, which is pretty much just splitting it up into two triangles. So that distributes the weight to the edges too.
Each of us sketched 3 bridges throughout the valley. So one of the bridges I sketched was the tie-hack bridge, and I noticed that it had 1 arch incorporated into it. So Margot and I incorporated 2 into ours to make it sturdier. And
so tension is the force pulling apart, and in our bridge, the tension is on the bottom. So, because these are compression pushing down, and this one's pulling apart.
Compression is one of the main keys to a bridge. It holds everything together. Compression is pushing, and as you heard, tension is pull. Compression build is to me the most important part of the bridge.
Sabrina and I put in our bridge is redundancy, and redundancy is basically having more than one critical component in your structure. Like we have more than one of each beam to support if one breaks, the other 2 will take the weight. And our building also uses redundancy because we have several beams on our ceiling, and just in case if one fails, all the other ones will hold it up.
Yeah, and so all right, let's give Keaton and Brevin a round of applause. You can go into the main bucket as well, Brevin, if you want. So you can see the whole thing compressing. Remember, Max was talking about that compressing force. Wow. You can see the whole thing compressing up top. You can see the tension force down at the bottom. It's like a tug of war.